להתחיל? רותי? רותי? Good afternoon, everyone. It's my pleasure to present Professor Thilo Rehren, who is a Leventis professor for archaeological sciences and director of the Science and Technology in Archaeology and Culture Research Center in Cyprus. Professor Thilo Rehren is a geologist by training. In 1999, he was appointed to a newly created chair for archaeological materials and technologies at the University College London Institute of Archaeology. There, he built a major international research group for postgraduate students and postdocs. From there, Professor Rehren continued to Doha, Qatar, where he established UCL as a postgraduate training and research center of excellence in museology, conservation, and archaeology. He joined the Cyprus Institute in 2017, and ever since we are close neighbors. Professor Rehen's research focuses on the reconstruction and understanding of technologies, technological processes related to the manufacture of metals, glass, glazes, and ceramics. For this, he combines concepts and methods developed by the materials and natural sciences in order to shed light on the achievements of past craftspeople and proto-engineers. One of his achievements, I wouldn't bring them all because there are many and long, is during the, and this is a major one and has to do with what you're going to talk today, during the investigation of a set of bronze casting crucibles from the late Bronze Age capital of Ramses the Great in Egypt, Thilo discovered the first-hand evidence for glassmaking in that period. This led to a paper in Science in 2005 and a host of other peer-reviewed publications. Based on the experimental and analytical work of several of his PhD students, we now understand late Bronze Age glassmaking in much more detail, and I'm sure we will hear some of it today. Subsequently, Thilo has also made significant contributions to the study of Roman glass and the investigation of the formation of the earliest Chinese glazes. Professor Rehren testifies on himself that he's most proud of the students he has been working with, many of whom have gone on to lectureships and research positions from Cape Town to Beijing to London, Greece, Jordan, and North America. It is a great honor for us that you accepted our invitation to come and give a talk in the school seminar of archaeology.
Right. Thank you, everybody, for having me here, and thank you, Zilla and Professor Winkelstein, for inviting me. And it's a real pleasure and honor for me to finally come to Haifa as a professional visitor and not as a tourist or as just a good colleague. And I very much look forward to many more and in-depth collaborations and visits and joint projects, because as Zilla said, we are neighbors and we have so many shared interests, there are so many possibilities, and it's just time to actually do it. And time is what we need, but as a geologist, I know we have a few billion years of time, but let's grab it. So, without wasting any more of that, today, and recognizing that this is not a seminar for advanced master students in archaeological material science, I want to talk a little bit about the trade in colors as it happens in the shape of glass in the Eastern Mediterranean during the Bronze Age, as one of the things that bothers me for quite a few years now, and where still an awful lot of work and research needs to be done. So first of all, why are colors so interesting? Color is a real luxury, and if I look around and see how we are dressed today and how we have a red top here and a green top here, the availability of color today is quite an anachronistic and unusual phenomenon. Color in the past was much, much more restricted. And if I look at settlements, at houses, at landscapes, I think in nature, in natural materials, we are much more restricted to just a few colors that were routinely used. Architecture, mud brick. If you think of a nice late Bronze Age settlement somewhere in the Nile Delta, yes, you have the full range of the mud from the Nile, and then you have the green of the plants and the blue of the river, and that's about it. And if you look at Victorian England, you have red brick houses all over the place, but it's limited. And having the full range of colors is really exceptional. It's a luxury, as I said. So Çatalhöyük here, for instance, architecture built on earthy materials is giving you earthy colors. If you fire them, yes, they get a bit more intense. But the one with the white house here, the white building there already standing out, normally the colors are very limited in terms of what people are using. And even here, when I yesterday drove a little, or was driven around, houses, landscapes are limited. There is one blob of bright color in there, and that has a very significant meaning, obviously. But then we get this, and you see it outside here as well. Why do we enjoy spring so much? The emotions that come with the cherry blossom in Japan, as it were here, or just the sheer joy that colors of the spring flowers bring us. But flowers, they don't last that long. The color doesn't preserve. You can get some of it into your wool in dyeing, but again, that's a limited range of colors. And that makes these stones, these colorful stones, which today a jeweler would dismiss as semi-precious stone, in the late Bronze Age, this was high-end precious stone, fantastic material. From where, do you remember? That lapis lazuli has to come from Afghanistan if we are in the Bronze Age. More recently, you can get it from Chile, but that's not an option in the Bronze Age. And if you get an Egyptian figurine carved out of it, that stone has traveled a lot to get there. It's not an everyday easy, you go to a shop next door and buy the stuff. Or if you want the turquoise colors or the amethyst, that's real jewelry stuff. To get amethyst, where do you go to get amethyst? Brazil, Madagascar, Siberia. It's not an option if you're in the late Bronze Age. There's one quarry somewhere, southern Egypt, up the Nile, and then turn right a week's walk inside. And Pharaoh was organizing real expeditions to mine that stuff. But it's expensive, it's limited. So if we talk about glass now, we are talking about that type of glass, not this type of glass, which is transparent and plastic, in fact. And just for the fun of it, I'll pass around one piece of glass. And don't be afraid, it's not a real one. Well, it's a real glass, but it's a modern copy of it. But that's what we understand with glass in the late Bronze Age: non-transparent, color, intensively colored, multicolored, polychrome, and not everyday functional objects, but high-end elite material. So what do we know about it, and why do we want to study it still? We don't know really, or didn't know until recently, where the idea of making glass came from. It appears very late. Metals we have been making from ore for 7,000 years. 5,000 BCE, you see metal smelting appearing in various places. Ceramics, pottery Neolithic, long ago. This glass stuff only appears about 3,500 years ago. 1500, 1550 BCE, somewhere there. Emphasis on somewhere. We assume it originates in Mesopotamia for a number of reasons. It took serious research for people to agree, yes, it's been made from plant ash, which is not the ash of any plant, but of very specific desert-growing plants or beach-growing plants, which can deal with a very salty environment in such a way that they actually absorb the salt with the groundwater, excrete it internally, put it in a pocket in their tissue, and enrich it there. And when you then harvest that plant and ash it, burn it, you get 20% of weight ash, lots of that being the sodium from the salt that the plant has accumulated. And quartz, as in the sense of white pebbles, not sand, but white, very clean pebbles as a raw material. And we have very good evidence for it being exchanged and traded, as I will show in a second. But the ubiquitous availability of the raw material, quartz pebbles, desert plants, at least ubiquitous in the Middle East, makes it difficult to say it has to come from here, like say with copper, which has to come from Cyprus, of course, unless it comes from Timna or Finan. But it's much more restricted in terms of where things come from. So archaeologically, we also, by the nature of the profession, until recently, we are pretty limited as to what we see of the whole past picture. If I look at Egypt, people were much more interested in excavating palaces and temples and big structures. Some bias there. Dead people are much more interesting than settlements, it seems. But still, there was some evidence for the manufacturing, the working of glass, thanks to Sir Flinders Petrie, 1890-something, but very little evidence for the actual production of it. Now, if you think, what type of evidence would you expect? If you make pottery, you have cases routinely where you overfire some of your pottery in the kiln, the wasters get thrown away for us to find and be happy and define that's a production group of that ceramic and the shapes and the composition. If you do metals, it's even better. For each kilogram of copper, you can expect several kilograms of slag to be thrown away, which is a fantastically well-preserving material, very informative to study. But if you make glass, you just fuse things together. You take your ash, you take your quartz with a pinch of something to give color to it, and that's it, the product. There's no waste. And if there's a bit of leftover plant ash, that dissolves with the next rain. And if there's a bit leftover quartz, okay, look, your geology is enough quartz rich, you won't recognize that. So there's a reason why glass making has been so invisible archaeologically. And that meant we never really know what we were looking for when starting to look for glass making. And that's, as Zilla said, actually, I didn't start out looking for it. I just stumbled across it. Now, further background, why is it exciting to see that in Egypt? Because if you look at the historical approach to glass making, as I said, we assume, based on various arguments, it's a Mesopotamian invention and appears 50 years later in Egypt. Part of the reasons for that is actually because we have historical evidence for Egyptian pharaohs bragging that they brought in Syrian glass workers. They brought in loads of glass into the country for the benefit of the country, implying it needed to be imported. And there are other reports on that import from the East. So here's an example, a temple with lots of dedications of goods being brought in. And if you see here heaps and heaps of stuff, and some of them are round cakes of something and some are lumps of something. And they're all nicely labeled. Now, I'm not an Egyptologist, I can't read it to you, but I believe my colleagues who then say that some of that is saying this is lapis lazuli from the mountain, and this is lapis lazuli that flows or from the kiln or something, and it's next to each other, and it's the round and blue ones that I'm interested in. And apparently the haircut of these people says they are from Syria, and therefore it's again glass coming into Egypt. But if you look at the excavated record of glass objects, they are mostly from Egypt, found in Egypt. Better dry conditions in the tombs than in Mesopotamia, where it's much wetter, and also different excavation traditions. And then we have that Uluburun shipwreck, 175 of these glass ingots, round cakes, blue. Sounds somehow familiar. So that's what we are talking about. And of those 175 ingots, 170 are blue, dark blue and light blue, but blue. One turquoise, one or two different colors, one amber, and that's about it. A very narrow range of colors, which will become important. So that's how we envisage. I think there are people here in the audience who know better about shipwrecks than I do, so I'd rather shut up and skip that. What I want to point out, though, is here, the Akhenaten, Amarna, this gentleman setting up a new shop, setting up a new religion and everything, and having part of his diplomatic archive preserved, which includes letters where he instructs people in the neighborhood to do things. So the letter here says, because I have been told the letter is speaking, say to Idea, the ruler of Ashkelon, thus the king, Pharaoh, speaks. He herewith dispatches to you this letter, saying to you, be on your guard. You are to guard your place, the place of the king where you are. The king herewith sends to you some other gentlemen. And by the way, remember, the king is strong like the sun in the sky. For his troops and his chariots in multitude, from Upper Egypt to Lower Egypt, rising of the sun to the setting of the sun, everything is perfect in my land. So he has a bit of an ego issue here, but fine. And then the reply, not that reply, but a reply. Say to the king, my lord, my son, my God, the sun from the sky, this is a message from Sitatna, your servant, the dirt at your feet. I prostrate myself at the feet of the king, my lord, my son, my God, 7 times and 7 times over, at the feet of the king, my lord. Okay, that's apparently the opening of any of those letters, but it gives you an idea of the hierarchy between the people here. I have obeyed the order of the king's commissioner to me to guard the city for the king, my lord. I have guarded very carefully. Good, fine, thank you. What matters is my king, my lord, has written to me for glass, and herewith I send 50 units by weight to the king, my lord. So even though the king, everything goes well from the upper land to the lower land, he still needs to ask the dirt at his feet to send the glass. And it's not just one, there are more. To the king, my lord, my God. So we have been there. To the king, my lords, having ordered some glass, I send 30 pieces. Who is a dog that would not obey the orders of the king, my lords, the sun from the sky, the sun whom the sun loveth? So, yes, hierarchy. The king, my lord, has written for glass from Tyre now. I give to the king, my lord, what I have, 100 units. So think of the 175 from the Uluburun shipwreck, and that puts it, I think, kind of in a good context. Whatever glass I have, I send to the king. So any glass is welcome. Obviously, Egypt can't make its own glass, can they? And if you look at the word kyanos, the Greek kyanos for glass, or the cyan blue color in your printer cartridge, cyan is blue, kyanos, kawana seems to be a Hittite word for glass, so there's another reason to assume it comes from Mesopotamia. The tablets, the inscriptions, all of that. Production in Mesopotamia, the P, we don't know. But the working in Egypt, we have good evidence for that. So that's where we start. And then that site in Kantir, Pi-Ramesse, that new kingdom site of Seti and Ramesses II, a long-term excavation project from the Pelizaeus Museum. They found in the 1960s, 70s, when they started planning it, a big structure in the Nile Delta on the surface and thought, oh, another fine palace, let's excavate it. Well, it was a factory, and I'm very pleased with that. And I actually suggested to Edgar Pusch at one point he should publish in the Journal of Nautical Archaeology, given how wet the stuff is, but he didn't like the joke. So it's not Egyptian archaeology as in desert, it's the Nile Delta, and you dig that deep and you hit the water table, which will make an important point as we progress in the talk here. But also importantly, we are situated here, fighting the enemy in the east. Sounds kind of familiar, the evil empire here, over ownership of who dominates the Levant, the riches of the trading cities, and trying to re-establish Egypt as a new big capital. So that's what we found when the museum brought me in to look at the copper bronze melting crucibles, which I don't show you here. Hundreds and thousands of fragments, a nice bronze casting industry. Exciting stuff, different lecture. Among those crucibles were these beauties, which are very different in that, and I'm sorry, I should have shown the others, in that they are cylindrical, kind of flat bottom, straight sides, and very vitrified on the outer surface. You see this shininess down here, that one in the corner down there in particular. They got heat from the outside, which is unusual for any crucible in the Bronze Age. And if you look at the break here internally, they have a funny white coating and layer here, which actually had been identified half a century ago in material from Amarna that Petrie had excavated 100 years ago. Mr. Turner, Sheffield glass professor studying those crucibles, found and identified that white layer as something important already. And among the less well-preserved sherds from those crucibles, tons, well, kilograms of them, and they all have this white layer on the inside as a very diagnostic feature. And then from the same excavation, but 1930s surface work, they found a red glass ingot. This one, which is now in the museum in Cairo on exhibition, and I'm not colorblind. If you look at it carefully where the dirt falls off, you can actually see red glass inside this. Now, you have seen corroded bronze. You know how corroded bronze looks like, green. And if that glass, which is colored by copper, sits in the wet soil of the delta for too long, it turns green on the surface. But if you take a fragment like that and cut it through, that's what you see. Red glass, copper oxide particles, red opaque glass, as opposed to the copper ions, which dissolve like salt in water without particles visible, making it blue. So there are two different types of copper coloration you can have, copper blue and copper red. This is one piece 2 centimeters across, so it's a magnified picture, a crucible part at the bottom. You see that white line separating it from the glass on top. There was actually a copper prill in the center that popped out, unfortunately, in polishing. Red glass, and then the green whitish corrosion of that glass from the wet environment. If you look at that piece from the outside, it looks either green or white or dirty, but not red. But having big enough pieces, you can argue your case that they used to be red. So that's what we found in the 1990s, and we're not quite clear what to do with it because, as I said, we didn't know what we were looking at, let alone what we were looking for. So with good painstaking work, Edgar Pusch identified 250 to 300 individual such crucibles, very standardized in their size and shape. Only about 50, 60 of those had glass stuck on the inside, enough for us to recognize the color of that glass. 50 of those were red glass. Only 5 with blue glass and 1 purple, amethyst. Now, if you mentally think of Egyptian glass objects from the late Bronze Age and the piece I gave passed round, which colors? Blue and yellow, white, but not red much. It's a very skewed distribution of color here. And they were obviously specialized in making these red glass ingots, like the one that we saw, which they lost 3,500 years ago. It's a very specialized workshop linked to the bronze casting workshop and the Egyptian blue making workshop, all mingled together with all their particular high temperature installations and processes revolving around copper and high temperature. And making copper red glass is a real art. People will tell you it's the most difficult of the traditional colors to make. So an integrated complex workshop and very specialized. And among that stuff, we found these, which look rather weird, stuck stuff, whitish, half molten on some of the ceramic. And when you look more closely, you see actually quartz particles stuck in there still, not fully molten. Having looked at quite a few of those, eventually we decided that must be the semi-finished, half-reacted glass, most of which we found not in these crucibles, but in beer jars, in reused beer jars to be precise, with the same parting layer, the same white line separating the charge from the vessel, where they first pre-reacted that and then in a second step in the crucible added the colorant to make the red glass as a second step. And as I said, a little bit of blue, 1 piece of purple glass, but conveniently stuck in the curve of a crucible, so clearly being made on site. Then we went back with the help of another PhD student to the Petrie Museum of Egyptian Archaeology in London, excavations 1890s, and looked at the drawers that people had looked at for 100 years and never bothered to look into more detail. And we see that porous whitish stuff. And Melina Smirniu, for her PhD, was allowed to cut it open thanks to the enlightened attitude of the Petrie Museum. Sir Flinders Petrie kept that material for study, sold the goodies to the paying museums to finance his excavations, but kept the really interesting stuff. And you see the quartz particles in that glass, in the cross-section here. So in Amarna, we have very much exactly the same material. We see or saw already the crucibles, exactly the same cylindrical shape, the same internal white coating as in Cantia. But the Amarna crucibles are all cobalt blue glass inside. No red, all cobalt dark blue. So, and now we go to the Uluburun shipwreck, 175 ingots, as I said. Paul Nicholson, last millennium, already identified by measuring them and visually identifying, this is dark cobalt blue, this is light copper blue, that the size of them correlates well with the color, and that the cobalt-colored ingots are both bigger in terms of diameter and thicker, 5 centimeter to 7, 8 centimeter thick, compared to the copper-colored, which are slightly smaller and thinner. Although they have the same cylindrical inside shape from the same crucibles as the ones in Amarna and in Cantia. So the same technology in principle, just a potter with a smaller hand making slightly smaller crucibles, or for whatever reason. So different workshop, same technology, but the different workshop goes with a different color. Cantia, almost exclusively red glass, Amarna, exclusively cobalt blue. Through analytical work, we know that copper blue glass found in Egypt has about 1% copper oxide in it, and 1/10 of it tin oxide. A clear sign that they used bronze as a source for their copper added as a spice, as a colorant into the glass to make it blue. While in Mesopotamian copper-colored glass, we only find copper, no tin. So even though Mesopotamia has higher tin access, higher tin bronzes than Egypt, they had a habit of using pure copper to make copper oxide to add into the glass. No technical difference, no technical reason, just different way to do things. So we begin to see structure in that industry here. The purple glass that I mentioned, the amethyst, is colored by 1-2% manganese oxide. Now, if I ask you now, what is manganese? Some of you will say, not quite sure. Others will say, oh yes, it's an alloying element in modern steel. And if I ask you, where do you buy it? Okay, good. They didn't even know manganese as a metal, but still they recognized it enough to collect it and add it to glass to make purple. A millennium later, as Yael will happily confirm, manganese oxide was added in routine operations to Roman glass for different purposes, not as a colorant, but as a decolorant, but that's again a different story. And there we assume it's somewhere here in the region. Yael, is it from the Sinai? Is that still what we assume, or do we not really know where it's from? Yeah, but there is manganese oxide in the Sinai. So for Egypt, it's not out of reach. There's some black glass mimicking obsidian, another precious, intensively colored stone. Very, very rarely we have really colorless glass in the late Bronze Age with nothing added in terms of colorant. So we see now, hypothetically extending what limited evidence we have, different workshops make different colors. Everybody can make copper blue, but the special colors, cobalt, you need to know where to get cobalt from. There's one source in the Dakhla oasis, which is not very suspicious. You need to know how to process it. Only some people knew that. Others knew how to make copper red. So there was some specialization, as well as common knowledge how to make glass itself to begin with, and how to make copper blue glass. And we know from Amarna that there were workshops, artistic workshops, which had access to all the colors, because we find rods and semi-finished products of polychrome objects in Amarna, even though the crucibles in Amarna are only cobalt blue glass making. So we see a separation of primary production of glass ingots and working of polychrome glass in a different set of workshop. So what I think would be nice to believe is that in the late Bronze Age, with all your elite exchange networks, and you are trading slaves and wood and craftsmen and women and cattle and gold and whatever you can trade in, you trade also different colors of glass. And if you want yellow glass, which imitates gold, you need antimony. For heaven's sake, where do you get antimony from? Okay, go to Georgia, in the Caucasus. Lots of antimony there, antimony beads and antimony this and that, alloys. And maybe they provided the raw material to make yellow glass, which then somehow was traded into Egypt. Also the white glass, silver imitating, needs antimony. So you could see individual workshops specializing in their own color, but exchanging with everybody else what other colors everybody else was producing, so that their artists had access to the full rainbow of colors. Imitating all those precious stones, which you could mine, of course, but if you mine a piece of rock, you are limited in the quantities and you're limited in the size of the block itself. And this is where I realized that I forgot to put in one more slide that I wanted to show of a headrest from Tutankhamun, a piece about that tall, that wide, where he would rest his head on in sleeping, weighing 2 kilograms in fantastic dark blue glass. A single piece of glass, much bigger than you would ever carve out of lapis lazuli in a single piece. Even for scarabs, fist size, you would often assemble different stones together. So making artificial precious stones opens up lots of opportunities that you won't have with the precious stones themselves. Here, just to introduce the next thing, some of the working debris that Petri excavated in Amarna, these trails that we now know were used to soften in the heat and then spin around a core of ceramic friable material to shape your object. And then you poke in and scratch out that ceramic core and you have the vessel like the one that's passing around somewhere, which I would like to have back at the end, please. It's important teaching material. So we see how that worked, and also from that you see that you can't really scrape out the inside very cleanly, and therefore you don't want transparent glass because you would have that rough internal dirt always visible. With opaque glass, it's not a problem. So we see that, how they made these shirts, not shirts, they made the whole vessels actually. This is a real piece, and you see a lot of yellow glass, a lot of white glass, and a little bit of blue, right? If we turn that on the side, not right. It's 90% blue glass, just a little bit of inlay of white and yellow pushed in from the surface, but the whole bulk of the body is blue glass, ordinary blue glass, while what you see actually from the object is not these individual trailed colors used to wrap while soft onto the body and then smoothen it in, but what you see is the polychrome object with all the exotic colors, which are probably much more expensive to bring in from abroad, and therefore you show off that stuff. You don't show the ordinary blue that much. So how do we now fit that looking outwards, out of the Egypt and Mesopotamia thing? The Mycenaeans were very fond of their glass jewelry. Some glass beads there on the side, very specific style, clearly made in Mycenaean workshops. But were they also making the glass, or were they getting the glass? So if we look at glass from Egypt and Mesopotamia, where we are pretty sure both made their own glass, we see in the trace elements, titanium, zirconium, these are parts per million, So if you have 1,000, that's 0.1%. In zirconium, we don't even reach that, very low concentrations. But you see a significant difference between glass found in Mesopotamia and glass found in Egypt. They have both trace elements, but at different concentrations. Andrew Shortland has to be credited with that. And also with this even more powerful graph, chromium and lanthanum, even more weird elements. Mesopotamian glass, more chromium, less lanthanum. Egyptian glass, less chromium, more lanthanum. Now, glass is made from, what did we say, plant ash and quartz pebbles. If you ask your botanist, plants don't eat chromium and plants don't eat lanthanum or titanium or zirconium for that matter. And if you ask a geologist, quartz pebbles don't have that stuff either. So where does it come from? From the stone tools that you use to grind and crush your quartz pebbles to a fine flour. We have done the experiments and seen that you get 2% dirt from your stone tool into your quartz, and that differs different stone tools in Mesopotamia, more basalt, and different stone tools in Egypt, more granite, that matches that signature. So the Aegean glass, all blue, all cobalt blue and copper blue and white corroded, fits when analyzed nicely either when copper blue in the Mesopotamian or when copper blue or cobalt blue into the Egyptian. And I didn't tell you earlier that cobalt blue glass is an Egyptian speciality. Mesopotamia never really did that in the Bronze Age. So the Aegean glass, the Mycenaean glass, fits either or the other, but it's not a separate one. They got their glass first, the earlier ones from Mesopotamia, later from Egypt. And the Uluburun ingots, they have all been analyzed now, recently published a few weeks ago by a good colleague, James Langton, Bernard Gratus, Cemal Pulak, all Egyptian glass, cobalt blue, copper blue, exactly matching the Aegean glass and the ship probably on the way there. So analytically, we see a lot of glass being produced in Egypt. We have now 3 production sites archaeologically evidenced to make glass. And we see the export of that glass to the Uluburun shipwreck didn't make it through, and a lot of it going to Greece, and some Mesopotamian glass going to Greece. I don't know how many thousand objects from Egyptian glass have been analyzed by now, but I think there are 2 or 3 objects found in Egypt that have a Mesopotamian chemical signature. So for all your massive evidence for import of Mesopotamian glass into Egypt, analytically, we have nothing to show for. What's going on here? Why do we have such a massive discrepancy? Why is Pharaoh talking about bringing in all that glass, but not talking about the ships and ships of glass ingots he sent to the Aegean for whatever reasons? Now, if you are a ruler and you want to sell yourself to your afterlife people, of course you are proud of what you bring in. You're not bragging about what you have to give in exchange for that. Analytically, we have analyzed thousands of glass objects from Egypt, not that much from Mesopotamia. We have a very biased picture here as well, which may be and clearly is incomplete in a different way, but for its own good or bad reasons. We see simply different facets of the same, much more complex reality. So thanks to that analytical work, we can now identify much more production sites. We can clearly confirm, but modify the understanding of long-distance trade in glass. we see change, Mesopotamian glass still earlier reaching Egypt, later the Egyptian glass. I didn't show it, but we have Egyptian and Mesopotamian glass beads in the Bronze Age in Denmark, of all places. Why would the Danish want glass? Or better ask, what would they have to offer rather than Danish sweets in exchange for that? Any idea what would Denmark give? Amber. And another precious stone, which the Egyptians wouldn't get that easily. And of course, lots of other things Denmark has to offer as well. So, and we have the analytical tools to provenance our glass now as a pretty routine application. What makes me wonder now, these Amarna letters talking about people from Tel Brak, people from Tyre, from Ashkelon, from Karshish, sending glass to the pharaoh. Where did they get their glass from? If I talk to my conservative, some of my beloved Egyptologists, they will tell me glass is a royal commodity, tightly controlled in the palaces. Why does a dog at the feet of his master have 100 ingots of glass that he can send to the pharaoh who has to ask for it? Where do these cities get their glass from? Now, some of these cities are in a certain country where I'm now, and I'm waiting for the archaeologists to excavate a workshop with cylindrical crucibles in the Bronze Age to see whether they were making the glass here or were they just trading it. Well, no disrespect meant with that, but of course, lots of these are trading cities which were dealing with stuff from all over the place, not just homegrown material. But how royal is glass at the end of the day if it's available more widely? And where's the Mesopotamian evidence? We don't really know that. And that's already pretty much 100 years, actually, 1923, I think. No, 26, it says. Petri, when asked by some people, said a good deal more knowledge of the history of glass might become available when Western Asia was really opened up for proper investigation and study. But for this to happen, it might be necessary to wait for another cycle of civilization. And then, and probably not until then, one might really get to know for the first time what was the actual origin of glass making. Now, I would now like to challenge my Mesopotamian archaeology colleagues that now we have demonstrated glass making in Egypt. Now you show us glass making in Mesopotamia. Otherwise, I will say you imported all of the glass and never made your own. So we have a lot still to learn and a long way to go. But I don't want to bore you with all of that. I just want to thank you for your patience and say that glass making is interesting not only in the Bronze Age, but also very much so in the Roman period with fantastic glass work being done in Haifa and in Jerusalem, and in India, a major glass industry there, which helps us to understand a lot of the Roman glass making technically. That is my field laboratory in Cantir with Edgar Pusch, weighing some of those stuffs. Medieval glass making, even early modern glass making is very interesting to study and a lot of work to do. And even if you're a Paleolithic specialist, you can do your bottle glass being used for arrowheads in Australia. Thank you. Yes, please.
Thank you for the interesting talk. What can you tell us about the glass making installation? I mean, the smelting of the glass must have left something. You said that there are no residues from the glass itself, but the installation should be in there because it gets to such a high temperature.
Thank you. So you were asking about the actual glass smelting, glass making process, what we know about that. The temperatures are not that high. actually that stuff melts happily at 1100, 1000 degree even. And that's one of the things I keep not understanding, why it took us so long to come up with glass. That range of temperatures, the redox conditions, all of that, we mastered that 5000 BCE with metallurgy. There's nothing more demanding in glass than in metallurgy. So there's one big question for you. You remember I showed you that white internal layer of this crucible. I didn't elaborate of that. That is a layer of calcium oxide, burnt lime, with a bit of clay to make it sticky, applied on the inside of the ceramic vessel, which acts as a kind of non-stick Teflon separating parting layer, as Turner called it in the 1950s. A parting layer to enable you to have the liquid glass in the ceramic crucible, let it cool, and lift it out like that. I had a master student, Stephen Merkel, who now does interesting work on lots of other things. He experimentally did that and was able to lift, I think, 3 or 5 glass ingots out of the same crucible before it broke. Which is important because if we count 250 individual vessels in that one glass workshop, that probably means 500, 750 ingots being produced. But it's this non-stick parting layer that really makes a big difference and shows in all of the slides where I pointed it out as an essential thing. Then we know that, as I said, the mixing of ash and quartz, there is actually a little bit of slag waste forming, which is salt, rock salt, sodium chloride, which is a part of the plant ash, but does not react with the quartz. Otherwise, you could just take rock salt, but you can't. But that gets washed away, literally washed away with the next rain when you crush your glass. So there is really no waste other than the crucibles. And what little bit we see stuck on the crucibles when that non-stick layer was worn down and dissolved in the glass, so that there it did stick. Like a good glaze on ceramic is meant to stick.
Thank you.
Asa.
Maybe some quick question about the source of fuel and the type of fuel that was used in the whole section.
Can you please repeat?
The question is about the type of fuel being used for this. We don't really know. For typical glass making from the Roman period onward, it has to be a fuel that burns with a long flame, so that you can separate your burning from your glass to not contaminate it, but transfer the heat from the flame above the glass projecting down. You cannot do it as in metallurgy, where you mix your dirty charcoal with your ore or metal and the metal will just separate cleanly. Here we see that these cylindrical crucibles have typically 3 hot spots on the side, as if there was directed heat with a tuyere, a blowpipe maybe. So I would expect also there to be an organic waste, agricultural waste type of hot burning fuel, creating hot air and some ash glazing the vessel on the outside that you can direct with an air blast onto it. But we honestly don't know the type of fuel. Could be acacia trees, could be cut off this or that, could be mustard stems, any hot burning waste will do. But not pips or dung or anything slow burning, that won't do the trick. Yes, please. Yep. Yep. So there is very precious, the question is about the range of colors and whether they would mix colorants to make, say, from yellow and blue to make green, opaque green glass. There is a little bit of that, very little, and that seems to be mixed copper blue and lead tin yellow glass. So yes, they would be mixing colorants to make a new color. You have the white calcium antimony compound to make white, milk white glass. You would add that to copper blue to make turquoise, opaque copper blue glass. So they were quite aware of that, but I have never seen opaque purple, for instance. I don't know whether that doesn't work technically or whether that is culturally, because amethyst is not opaque. Amethyst is rock crystal transparent, so maybe they meant to have it like that. What is important, though, is yes, you can do that initially under controlled conditions, mixing different pigments, different colors, but you cannot recycle the glass. If you look at that cross section I showed you, if you remelt that, you just get a mess in terms of color. So as important as glass recycling is today and in the Roman period and everywhere in between, in the late Bronze Age, you can forget about remelting glass because of that polychrome problem. If you get an ugly brown, dirty something. Yes, there's one in the far back. Oh, the oldest evidence for clear glass. As I said, there's a little bit of late Bronze Age clear glass, mostly as beads, where you don't have that problem of the inside core that you have to scrape out. Now, I'm a mere geologist. I'm not an artifact-focused archaeologist, so I don't honestly know the date of these, but I would certainly in the late Bronze Age, you have some clear glass. We see it in the Hellenistic period emerging routinely for vessel production. And then in the Roman period, it becomes the mainstream dominant glass, I would say.
We're looking here at globally some also color textile.
Yeah, color.
Particularly the Tyrian purple, which is known as royal purple, and there is much that can be said in comparison.
Yes.
Conceptually, technologically, etc. What we feel is that perhaps we can witness various moments of rediscovery or reinvention of the same technology in various places,
Yep.
rather than continuous process of evolving, or one idea thrown into the Mediterranean and then just put it everything.
Mhm.
To what extent can you elaborate a little bit the last one?
So you started your question with the mentioning of the imperial purple, the Murex production, which is being studied here, and is exactly one of those examples how luxury and color go together, and color being the controlled substance here. Now, and then the loss of that high-end elite technology, the loss of the knowledge, and it re-emerges elsewhere in a different way. A lot of that happens in glass making. Some of it seems to be transitional. And when you leave the Bronze Age and you collapse your system of international exchange, you lose your base for the polychrome glass production. And you change your recipe to natron, mineral natron, rather than plant ash, which has other side effects. There is still a continuum of technology. But on the other hand, you go to China, where the Chinese in the Shang dynasty, in the Zhou Iron Age warring states, down to the warring state, had seen, faience have seen imported Central Asian, Western Asian glass beads. And in the Han Dynasty, so that's, I think, 220 BCE onward, we suddenly see the Chinese making their own glass using barium and lead as the main constituents and silica. Totally, utterly different technology to what the glass beads were making in the West. But if you look at value stones in China, you automatically think jade. And jade has this very milky, unclear color between white and greenish and yellowish, and exactly that very ill-defined, milky, transparent appearance is what that lead barium glass does, which is very different to the striking, strong glass colors that we see in the West. So they invented a totally different technology to make a product that suited their value system as to imitating their precious jade, rather than the Western precious stones that meant less to them. And then you go into the 12th, 13th century CE to Nigeria, Ile-Ife, and you see people using buckets that big, crucibles of extremely high firing ceramic with blue glass, cobalt blue glass in it, with copper blue glass, with red glass, based on feldspar quartz and the shells of African snails as a calcium source, popping out of technological thin air, or rather rich air, because it's the same time as the Benin bronzes, very high-end metallurgy, and glass bead making. Suddenly, after 500 years of imported glass beads from India and East Africa, from Arab world through the Saharan trade, suddenly somebody invents in Nigeria, again, a different recipe, but making the same glass, blue glass, that the beads were so important. So you have lovely examples for that independent discovery, imitating something they had seen before. Any other questions? Yes.
Question, but this industry is functioning like along ions in the electron big. How do they compare in terms of like consumption? Is ions just easier to make, or is it a specific choice by site?
Sorry, which period are we talking about? The difference between... So the faience industry in the late Bronze Age and how that differs from the glass industry, is that? Yeah. Well, faience, that is these sand crushed quartz cores, shaped wet, then fired in a bakery, as it were, forming a glaze on the top surface, colored blue again with copper, is basically the ordinary man's glass. That's absolutely mass-produced. It was on the slide. I didn't mention it in Cantir. They have found tens of thousands of molds to make these mass-produced faience beads and inlays. And you see that in terms of jewelry everywhere. It's a very common material. From the outside, I have looked at some faience. I'm not sure. Is it faience? Is it glass? So it can be damn good imitation. But it's a different technology. You shape it cold and you fire it to make the glaze. While glass, you shape it when hot. And so it's again a different technology, but it shares the same raw materials in different proportions. Good. Any more questions? Yes, Sila. The manganese. Yes, I mentioned you find it in the area. As I said, I think that there is a manganese source in the Sinai. isn't Timna part of the Sinai, Negev, somewhere there? Let's be generous. I appreciate it's a sensitive field. Sariel, what do you?
It's highly common in the Negev as well.
Manganese being common in the Negev, yes.
Iron oxide.
Yes. The problem with the manganese nodules or crusts is they look identical to iron oxide crusts, and you need to know what you are picking up. It's all black, brown, dark. So it does exist, but I wouldn't know exactly where. Lots of manganese in Cyprus, yeah. We have lots of manganese-rich copper slag, 20–30% manganese oxide instead of iron. No, but I would rather assume they took the manganese from the Sinai than from Cyprus. If you are a glass maker in Egypt or in Bet Eliezer or somewhere. But again, another example of more research to be done. We know from the 6th century CE, 5th, 6th, 7th century glass, there are at least 2 different manganese sources. One has more strontium, the other has more barium. So we don't know where, we only know they are somewhere. That's why we need students to actually fill the gaps that we white-haired people leave and to correct our mistakes. So the onus is on the next generation to do a better work. And that's what I'm, as you said earlier, most proud of my own students continuing the work and proving me wrong. Otherwise, I'm not satisfied with them. Thank you. So, and somebody has a piece of glass for me, please. Lovely.